So today we talked about reducing fractions to lowest terms, proper and improper fractions, and um, sums containing improper fractions. All right, so that's on page 71, 73, and 77 in your book. Okay, so if we are going to simplify a fraction, let's find a fraction and we will work on simplifying it. First fraction I'm going to work with here is 5 over 30. Okay? All right. Now the first thing that you need to do is find out what the factors are of 5 and of 30. Okay? If you remember, factors are two numbers that you multiply together to get a product, right? So we are trying to find factors that we can multiply together to get these numbers. Okay, so first let's look at 5. All right, the factors for 5 are, well, we can multiply 1 times 5, and we can multiply nothing else. Okay, for 30, we can multiply 1 times 30. We can multiply 2 times 15. We can multiply 3 times 10. And we can multiply 5 times 6, correct? Okay, now that we've found out what factors are in both of those numbers, just like when we were looking for the greatest common factor, that's exactly what we're doing right now. We need to find the common factors of 5 and 30. And in this case, our common factors are, let's see, if we look at these, we can see that our common factors are 1 and 5, correct? Okay, so we're going to write down our common factors, 1 and 5. Now the largest of these two numbers, or the greatest common factor, is 5, correct? So our greatest common factor is 5. Now that we found the greatest common factor, our next step is to take our fraction, okay, 5/30ths, and we're going to divide both the top number and the bottom number by our greatest common factor. Okay? All right, so what we're going to do here is we're going to take 5 over 30, or 5/30ths, and we're going to divide the top and the bottom by 5. Okay? And 5 divided by 5 is equal to 1. And 30 divided by 5 is equal to 6. And if you recall from our last session, if you remember this right here, this fraction is equal to what? 5 over 5 is equal to 1, right? And any number divided by itself is what? Is itself. So that means that 5 over 30 is the same thing as 1 over 6, because all I did was divide this number by 1. Okay? Does that make any sense to you? All right. Okay, let's try another one. Okay. So let's try 15 over 33. Okay? All right. So what we're going to do now is, first we're going to find pairs of factors for each of these numbers. Factors for 15, we can multiply 1 times 15, and we can multiply 3 times 5, right? For 33, we can multiply 1 times 33, and we can multiply 3 times 11, correct? Okay, so now let's find our common factors. Our common factors are 1 and 3. Okay, so we're going to put our common factors over here, 1 and 3, right? Then we're going to find our greatest common factor, which is 3. All right, now we're going to take our original fraction, which was 15 over 33, and we're going to divide by our greatest common factor. So we're going to go 3 over 3, divide by 3 over 3. And again, this is equal to 1. So all we're doing is dividing this number by 1. And 15 divided by 3 is 5. And 33 divided by 3 is equal to 11. Right? Okay, let's try another one. Okay, again, we are reducing our fractions to lowest terms, okay? If we took 10 and 55, we know that the factors of 10 are 1 times 10, 2 times 5. 55, we know that the factors are 1 times 55 and let's see, 11 times 5. Okay, so when we're writing out our factors, factors of 10 are 1, 2, 5, and 10. And, oh, I'm sorry. I'm trying to write my common factors. I apologize. My common factors of these two numbers are 1 and 5. Okay, so our two common factors are 1 and 5. What is the greatest common factor of those two? Well, it's 5, right? Okay, and then we are going to take our original fraction, which is 10 over 55, and we are going to divide it by our greatest common factor, which is 5. And again, 5 over 5 is 1, correct? So 10 divided by 5 is 2, and 55 divided by 5 is 11. So our reduced fraction is 2 over 11. Okay? All right. The next thing that we talked about today in class was proper and improper fractions. Okay? So what I'm going to tell you is a proper fraction, okay, is one that has a numerator. The numerator is which one? That's right, the numerator is on top. So if I had 9 as a numerator and 10 as a denominator, this is a proper fraction. The reason it's a proper fraction is because a proper fraction is one in which the numerator is smaller than the denominator, okay? Because why? A fraction is a part of a number, okay? So this is a proper part of a number, okay? An improper fraction is one where the numerator is greater or equal to the denominator, okay? So anything that is greater than 1 is going to be an improper fraction. 10 over 9 is an improper fraction because the numerator is greater than the denominator, okay? 11 over 11 is an improper fraction. Why? Because this 11 over 11 is equal to 1. Any fraction that is equal to 1 or greater is an improper fraction. Okay? All right. So, the next thing that we talked about was changing improper fractions into mixed numbers. Now, how is that possible? To change an improper fraction into a mixed number. Well, if you recall, I told you in the past that one of the ways a fraction can be read is as this is read as a divided by symbol, right? So this can be read as 44 divided by 9. All right? If we write 44 divided by 9, okay? So if we write 44 divided by 9, all right? If we write that, that's how we write it, okay? And if we go ahead and divide this out, 9 goes into 44 how many times? Well, 9 goes into 45 5 times, so it's 4 times. 4 times 9 is 45, or excuse me, 36. I'm crazy. All right, so when we subtract, okay, we're going to borrow. 14 minus 6 is 8, right? So we have a remainder of 8. And if we wanted to make a remainder a fraction, it would be 8 over 9, okay? So 44 divided by 9, or 44 ninths, is the same thing as 4 and 8 ninths. Now, why would you believe me, right? Well, let me show you why you would believe me. I have some examples here. One example would be, I am going to give you the example of 6/7. Oops. This is going in with my addition. Okay. Well, that's okay. We can move on to that because that's the next thing that we did. We did addition of improper fractions. Okay. When we add improper fractions, we add them and then we simplify them. When we simplify them, we change our improper fraction into a mixed number. Okay. So in this case, where I have 6/7 plus 3/7, again, we keep our denominator, right? We add our numerators. 6 plus 3 is 9. Okay, so my answer is 9/7. Okay, if I simplify this and change this into a mixed number, okay, I'm going to say 9 divided by 7, okay? So 7 goes into 9 how many times? Once. 1 times 7 is 7. 9 minus 7 is 2. So I have 1 and 2/7. Okay? So this is equal to 1 and 2/7. Now, how do you know that that's true? Well, I'm going to show you a visual to prove to you that's true. Okay? On this circle, I have it divided into 7 pieces. Okay? I have 1, 2, 3, 4, 5, 6 of the pieces shaded a yellowish green, right? All right. I have a second circle, and on that second circle, I have 1, 2 of the 7ths shaded pink, and on this one, I also have 1 shaded pink. So the number of 7ths I have shaded pink is 3, right? So if we look back at our fraction, we see in yellow 6/7, right? We see in pink 1, 2, 3/7, right? And when we put those two together, what do we have? I have 1 whole and I have 2/7. So I have 1 and 2/7. Is that what I got for my answer? Yes, it is. It's also, see 9/7? It's also 9/7, isn't it? Because if I have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ha ha ha. Does that make sense? All right. Should have had the camera higher on this one. Maybe I can raise it up a little here without causing problems. Hopefully. Hopefully, right? All right, let's try a second one. Okay. What if I had 2/3 plus 2/3? Okay. Again, first we keep our denominator, which is 3, and we add our numerators. So 2 plus 2 is 4, correct? So we have 4/3. Again, if we want to simplify that, we say 4 divided by 3. So 4 divided by 3, okay, 3 goes into 4 how many times? Once. 1 times 3 is 3. When I subtract, I get 1. If I write my remainder as a fraction, I have 1 and 1/3. So this is equal to 1 and 1/3. Again, I have a visual for you. Okay. What do I have? Here I have 2/3 in blue, right? Here I have 1/3 in, I have 2/3 in orange, right? I have a third here and I have a third here, okay? All right. Now, up here, I have my answer, 4/3. 2/3 plus 2/3 is equal to 4/3, okay? It's also equal to 1 whole and a third, okay? Now, that's the thing that you have to realize when you're looking at improper fractions. You are looking at more than one whole piece, okay? Another example would be, let's see, sixths. Let's do 5/6 plus 2/6, okay? All right, again, we're going to keep our denominator. We're going to add our numerators. 5 plus 2 is 7, so we have 7/6. Again, that's 7 divided by 6. So we're going to say 7 divided by 6. 6 goes into 7 once. 1 times 6 is 6. When we subtract, we get 1. If we write our remainder as a fraction, we have 1 and 1/6. Okay, so this is equal to 1 and 1/6. All right, again, proving it to you with a visual. Okay, what do I have here? First, I have a circle cut into 6 pieces. Okay, I have 5 of those pieces colored in. 1, 2, 3, 4, 5. Okay, blue. Then I have another circle into 6 pieces. Okay, I have 2 shaded in orange, one here and one here. So I have 5/6 and 2/6, right? 5/6 plus 2/6 equals 7/6. Is that right? 1, 2, 3, 4, 5, 6, 7. That's right, it's 7/6. If I did my division, 7 divided by 6, I came up with 1 and 1/6. Is that what I have here? It is. I have 1 whole piece and 1/6 of a piece, okay? So always remember, when you're doing improper fractions, you will have more than one whole, okay? Your denominator is the number that you've divided each whole piece into, okay? In an improper fraction, your denominator is the number that you've divided each whole piece into. In this case, each whole is divided into 6, okay? The numerator is the number of those pieces that you're using. In this case, in total, we are using 7 of the 6ths. Okay? Makes sense? I sure hope so. Good luck.